And welcome to the Agentic Quality Podcast. Today, I have Vasu Jain with us, who is a developer at Amazon Ads. And they have to deal with a lot of agentic systems, testing agentic systems, and building pipelines to deliver those agentic systems to production. So I'm really excited to talk to him today. Welcome, Vasu.
Thank you for the introduction, Tatiana. It is nice to have be here on this podcast.
Vasu, tell us about yourself and what you do at Amazon Ads.
Yeah, absolutely. So as you know, my name is Vasu. I'm a senior software engineer at Amazon Ads. My team currently owns the ad server, and this is the system which is, I would say, a brain behind telling what ad to show to a customer. And it does it all at real time, figuring out which is the right ad to show to a current customer. It conducts the auction. It has like a really low latency budget. So that's pretty much like what I work on a daily basis, an ad server.
Right. And so, what's at stake when something goes wrong in that system?
So that's a good question. So if something breaks in the ad server, you can think about you're watching a Prime video and suddenly an ad break comes, but instead of showing an ad, it shows you a blank black screen.
Right.
That's what happens when an ad server breaks. You don't get an ad back and you will see a blank screen. Similarly, if the system breaks, you're shopping something and instead of seeing the bestseller or sponsored products at Amazon website, you will not see those recommendations. So in a nutshell, there's a lot of revenue on a stake that customer experience would be broken, as well as like we would lose the advertiser's trust. Meaning if we have delivered a goal that okay, thousands of the ads would be delivered in a week, but since we have broken our system, those ads would never be delivered and then we lose money.
Right. And so tell us more about how that system operates. I know that you guys have AI agents. What does that look like?
So traditional ad server I can speak about is an orchestration kind of ad serving where a request comes in, you have to figure out the data that you need to enrich in that request, and enrichment can be done through agents, enrichment can be done through different standard libraries, and then that request has to pass through different bidders. Bidders can be somebody who are interested in returning an ad back for that particular request. And then once we get all the ads back, we conduct an auction. You can think of auction as like a standard auction that happens like even like during garage sale. Whoever gets the best price wins that item, right? So similarly, that impression opportunity or the ad opportunity goes through an auction where the highest bidding agent bids on that particular impression and tell that okay, I'm going to pay $10 for this ad. But then there are some rules that okay, is it like a kid safe ad, is it like brand safety and whatnot. So it's a complex system, I would say, which sort of like goes through a lot of decisioning, auctions and enrichment, and then finally returning a right ad back to a particular programmatic bidding. It's all like automated.
Great. And so what makes testing this system difficult? I mean, we can see already the complexity, right? But what are some of the specific challenges?
Yeah, so if you think about the classic testing approach, right? How do we test a particular system that, okay, I have sent this input, can I expect a particular Y output? That's what like a very high level test case looks like. But this particular test case will fall apart when you know that same X input would result in different outputs every time that I'm going to fire this particular X input to a system. And that's what happens with an ad server. You send a request and after 5 minutes, you will get a very different response. And the reason is because there is so much auction dynamics, right? The budget has been done for a particular ad. There's a pacing score that is changing. There is a brand safety rule that is being applied after like 1 hour because you don't want to show a customer same ads over 100 of times in a day, right? So those are like some of the changes that are like making it very non-deterministic and hence very hard to like apply standard testing procedures on this kind of system.
And I know that you built a framework to test the system, but can you tell us how you were testing it before the framework was built?
So before this framework was built, my tests were like very flaky. The tests were written in a traditional testing style that if I send an X request, can I get a Y response back? And hence Y was not coming always the same. it used to fail hundreds of times in a day. And once it used to pass, then only we used to get some confidence that okay, yeah, the change is perfectly fine to get deployed. That's how the testing was before. But when I was given this problem that hey, our testing is like so non-deterministic, and we don't get like enough confidence when we are doing a deployment. How can we make work better? That's when like I came up with the behavioral driven testing approach, where I don't really care about the non-deterministic part of a system. I care about the behaviors that I expect from a particular input, and am I able to validate the behavioral correctness of those all components in the ad serving? Are those being performed the way they are supposed to perform? Given the non-deterministic part, we have kept it outside of the validation scope.
And so, can you tell us more about how that framework works?
Yeah, the core idea behind the framework was that you should stop testing the outputs validation and start testing the behavior. Instead of like checking for did we return add ID of 1234 back to a particular input, we ask this question when writing a test. Did we respect the price that we have sent in a request? Is the price correct when it comes from a request? And did we pick the right price for that particular ad or not? Similarly, instead of like we looking out for a correct output, we started looking into did we call a particular chain of services in a right order or not? Did we make sure that this particular validation has been done when we are getting auctions being like conducted on a particular ad request? So we started like validating behavior instead of validating the correctness of the output.
And so you basically create this list of rules, probably based on the specification, but you probably are defining some of your own rules to validate the right behavior, right?
Yeah, in a nutshell, yes. So you can think of this that, okay, if there are like 5 steps in a process and all of those 5 steps, when being combined are returning you a non-deterministic response. Is there a way for us to like validate each individual steps alone? Can there be a non-deterministic response when they are being tested alone? So that was like a high level methodology that I used. So if I have like 5 plugins being called, instead of me testing all 5 together, I started testing one at a time. That if I have sent a request to a X plugin, has X plugin been executed successfully? Was the response in the correct format? Was the response in a returned by that plugin was like in an appropriate correctness or not? So that made it like behaviorally like validated and made the testing very easier.
And what was the result? Basically, what has changed for the team? How did that impact your processes and your delivery?
Yeah, it changed the night and day, I would say. Before, like our integration test used to broke consistently on a valid change. Some developer have deployed a change, but testing are failing because we are trying to look for a response and add ID back from our dependencies response, which might not be there because the campaign has expired or the response is not deterministic. And we used to like manually intervene the pipeline, see like if this is a right change or not. It was all manual, and it used to like, I would say, take we used to do like 4 deployments in a month. That's it, when the tests were like failing. But once we built this framework, behavioral driven framework, we started gaining confidence that our change are safe. We started with like seeing an increase in the deployment velocity, like once from like 4 times a month to 4 times in a week. And then we saw a incredible jump that okay, over a year we have done like around 1,000 plus deployments without any manual interventions. So that was like the change result that we observed after implementing this in production.
And that's amazing. And I'm curious if that framework got adopted in more products or in different teams.
Yeah, so this product which I developed, which was like a framework, has been adopted in the ad org itself. That wherever like this non-deterministic piece of like complexity is in a system, people are like relying on creating or writing the test suites in a way that okay, they can make it like behavioral driven, where rather than looking out for a correct output, they start validating the behavior of their system or subcomponents of the system.
Awesome. And so, how did AI impact this process when AI entered the picture? How did it change what you're doing?
So in a traditional release cycle, you can think of like we have rollbacks, we have integration tests, we have canaries, we have different metrics to view and account for. When an AI agent came up, recently we did like some analysis of like solving some of the recurring problems that we had. So think of like if you have deployed a change and that deployment has failed altogether. A traditional human would do is look at the logs to figure out what has happened, why did it fail, try to figure out which commit has caused this deployment to be failed, whether the testing was a gap or some real change when combined together with other changes have made this deployment fail. So it used to take like around 40 to 50 minutes for somebody regularly to figure out why the deployment has failed. Now, when agents have came, what we have started doing is that this whole collection process where a human has to go, collect all the evidence, and then make a reasoning out of it that this might be the root cause of deployment to be failing. We automated this whole piece that earlier traditionally 1 hour was being spent minimum to figure out the deployment failure root cause. Now, agents, when given access through MCP to different tools and like different services, they gather all the information all together at a particular stage in production or in a release cycle, and then they gather all evidence, and then they make the reasoning out of it that okay, yeah, this might be the root cause because I looked into all this data, which traditionally human would have spent time by going there and figuring out data, capturing it, looking at the timestamps and whatnot. Now agents are able to do it very quickly because there's a SOP that has been already fed into them that this is the steps that you have to follow, and they gather all the data, provide it in a way that humans can read, understand, and make an interpretation whether this is the right root cause or not. So I would say agents have like complemented in debugging and figuring out the deployment failure in a release cycle, which traditionally would have been very slow because obviously it will take some time for a human to go and look into all those things because of the cognitive load on his mind and other things to figure out so much data and figure out why it happened. So that was like one aspect of how agents have helped in this release management. Similarly, like rollbacks, figuring out if the rollback should happen or not because of the dependency and whatnot. Anomaly detection, whether the metric has been like that previously and after the deployment also it remains same. There also like a small piece of judgment was required, and agents are doing pretty well there.
So you incorporated AI agents, as I understood, in production to monitor and observe what's happening and then troubleshoot the failures, right? And then you also have agents that help you with the release and understanding how confident we are in this release, right? But at the end of the day, there's still human in the loop who has to look at the results and observations and make the final decision, right? So, and I understand that you also have agents in other places in your DevOps and deployment pipeline. So, what other kind of applications or what else agents are doing?
So there are like different agents meant for different jobs. So there are like some agents which are purely looking into fixing merge from live. Merge from live is basically when there are like some dependencies upgrade. Let's say Java version got upgraded, or maybe there's a Rust version which got upgraded, or maybe there's a new like identity version that got upgraded. But when we make it merge to our particular like dependency graph, things can get changed, right? You have to look out for the backward compatibility. You have to figure out whether things are correct or not. And this used to be like a recurring problem once a month that you are trying to upgrade your versions and it's causing a deployment to fail. So we created a specialized agent just to look into like how they can sort of like figure out what is the right order of dependencies. If we are updating an X dependency, does it also need that Y dependency which relies on X has to be upgraded to a bump up version or not? So this was like one use case that we created a specialized agent for. Another one was anomaly detection, which I was talking about. That sometimes what happens is that you are already seeing a problem in production due to some n number of systems outside of your scope, but the deployment has to go, and when deployment goes, your metrics are being looked badly because there is an issue going on in some systems which is not in your control. Now, traditionally, rollbacks, what they will do is they will roll it back because the threshold has been breached. But that threshold has been breached not because of your change, but because a system outside of your control has having an issue. So anomaly detection, what that agent, what it does is it looks at your previous state before a deployment and tries to reason that, hey, this has been like this even before when I deployed this change. Now, do I need to like roll it back or not? Because my change might not be the reason for it to cause this problem. So we did that kind of anomaly detection agents as well, which looks at like previous state before the deployment and make a reasoning that is it valid to like roll it back or not.
I like that the agents start reasoning with people and they kind of become an equal partner basically, but sometimes they have even more context and know a lot more than us because we didn't spend time investigating what they could investigate. And so that sounds like agents are helping us a lot and save us time in many different areas, right? Like you said, like it could save an hour investigating, it could save researching the merge, right, which would take us like days sometimes to do with the big changes. So how much would you say time like it saves overall? Like if you look like 3, 4 years back to now, like is there a number you can just throw to say like, hey, we're that much X productive?
Um, I I mean, sure. Like the number that if I have to come up with that, we have increased our velocity in terms of the amount of work that we are doing now. Historically, like as I said, my deployments used to have like one particular person looking into all these things and fixing it out. Now I don't need to like spend that much time in doing this. Like observability or like SRE work, I can spend that much time delegating the works to agents and then making a reasoning and spending my time in architecting a system or looking into other optimization. So I would say like at least 8 to 10x the productivity has been increased because now the the work that was like boring for an engineer to do is to like look at logs, do all those kind of things to like figure out what happened and why it happened. It has taken that part. Of course, like for some people that might have been like solving a puzzle or something like that, but a lot of people used to have like problems with doing that manual boring work of like connecting the dots by putting all the data into one single place, and
Yeah.
agents are doing it pretty well without even complaining about it.
Yeah. It does save us a lot of time on mundane work, like you said. But I'm also hearing the developers complaining that they don't get to write code anymore, and now they have to manage the agents instead. Like, does that bother you at all?
I mean, it doesn't bother me a lot, to be honest. I do see it as a change that is like a good change. Like if you think about like maybe 50 years back, there were people who were writing the compiler level code, right? And then a C++ language came, then a Java language came. Now you don't get to work on compilers. You were writing code on C++ and Java, which was like writing an assembly level code internally, right? Same thing I apply here. If you think that agents are writing code, yes, but who are orchestrating agents to get the right stuff done? You are doing that. So it's a good shift in mental model of like what an engineer is supposed to do.
Well, so this is all awesome and great, but let's talk about some of the things that go wrong when you use all of these agents. So, was there situations where you were like, "Oh, I wish I didn't have an agent doing this"? So, was there any things that happened like that?
Definitely there are like steering and a lot of like guidance that are needed when you're working with agents, right? That's why we have like human in the loop to make sure that you are doing the right thing with an agent or not, and you need to have some sort of like validation being done after a work has been done by an agent. I consider agent as like an intern or something who have recently joined, who knows or who have a lot of context of like how to get stuff done, but still like very new to this field. So whenever like I work with an agent, I use that mental model to operate at that level that okay, he or that agent can do the work, but the validation, it's sanity. I need to validate before I like say that okay, yes, this is done. Or if I'm not doing that, then I need to ask an agent to get it validated at some pre-prod stage.
We have heard about, horror stories when the agent deleted the database or, there were big, very expensive and costly mistakes that the companies faced due to AI agents, right? So it's definitely, we need to understand how much we can trust them, right? And what level of decisions we can trust them with and which ones we cannot. And I have talked to people who said, like, hey, we do let the agents run our pipeline and we only have like the last check that we're doing, but we do let agents make a lot of decisions. And so, but your definition is like, hey, as long as it's a junior level decision, basically, we're okay to do that, right? So where is that trust level? Like, how do you decide like at which trust level, at what level to trust them and not?
So I think of that as like at a decision boundary. So if I have to trust an agent, I have to trust what is the decision boundary that agent has. I would certainly not want an agent to have decision boundary to make a decision on a production unless he has done that in pre-prod and proved that it was right. So those kind of like tests which I like apply on myself as well, that if I am writing a code, I would want my trust boundary for that code to be proven in a pre-prod stage, then it should go in a prod. Same thing I do with the agent as well. I decide its decision boundary based on what the feasibility and what is the safety protocol for me is, and that's how like I increase its boundary once it has validated or surpassed the previous boundary that I have given it to him.
Um, yeah, I understand. All right, so let's talk about the system of we talked about before the agents testing other agents. Sorry, the agents talking to other agents. So does your behavioral framework addresses that as well, or how do you approach the system like that?
Yeah, that's an interesting question that like keeps me awake at night. Like right now, what happens is that you can't like write a unit test for an agent, right? That did the agent make a good decision or not? Because obviously, an agent has an access to an LLM, which is like a highly non-deterministic brain, I would say, and that's just like a very hard problem to solve right now. But what can happen is that you can definitely like validate whether the agent is able to make like a right that is moving in the right direction of a decision or not. And that's where like testing an agent becomes like a little bit challenging and different, because there's not like a defined inputs and outputs contract you have with agent. So if you are giving a prompt to an agent that, hey, here are the exact metrics, logs, and deployment state, can you verify whether the agent is able to reach to the right conclusion or not? And it might not do that every time because the data has been changing, right? So that's where I think behavioral validation is like very crucial for agents as well. But again, you can't like expect the behavioral validation to be same always. What you can do is you can probably like validate bits and pieces of it to say that, okay, yes, I can have like a certain confidence that, okay, yeah, this agent will do right in production, because the decision boundary or the access to it and the evaluation based on the previous questions that I've answered or asked this agent were like in this particular category, and hence it can do the job with that.
So we're still dealing with the risk management basically, because I don't think agents are 100%, like you're never 100% sure the agent is going to do the right thing, right? Maybe in rare situations. So you still have to take the risk of like 90% this agent is going to do the right thing, right? And then you cover that up with the observability on the other end and make sure that if it start doing the wrong thing, then you catch it early. Or how do you manage this risk?
So interestingly, like what we have done so far is that, because agents consist of an LLM and access to different tools. Now, when you give a particular prompt to an agent, it tries to reason using the LLM, tries to invoke different tools and different MCPs, and then come up with an answer. That answer can be a right, can be a wrong, or can be a partially correct answer. Now, let's say for a case where that answer has been partially correct, and you know that it's partially correct, it's not a right answer. How can you debug that? Now, because agent, if it's a black box, you don't know what an LLM has responded back to an agent, what MCP it has configured or called or invoked to get a certain output which an LLM has interpreted in a wrong way. So what we did is like we started like we 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 as in like we have created a framework where you have like started like tracing everything that an agent is doing beneath him. That, let's say, if it has invoked a particular MCP, we look into what was the prompt given to an LLM, that prompt was captured, what was the output that came from that LLM, what was the inputs that we have sent to a particular MCP, what was the output returned to an MCP. Now once we have that whole thing, we sort of like store it as a request envelope, that this was all the request, this was the response, and then we try to reason it with that particular trace ID, that hey, if this is a partially correct output, where did things go wrong, whether the prompt to an LLM by an agent was wrong, or whether the MCP output that came from a service was wrong. And that's how we are like trying to connect the dots, but it's still like a very hard problem. But you need data to correlate and retrain the agent or update its SOP.
And is this still a human doing this, or do you have the agents analyzing that as well?
We have an agent on top of like to analyze a particular trace ID, but still like you like for us to understand the where the things go wrong, you still need like a human in the loop to make sure that yes, this is the right piece of information that we have gathered from a particular trace ID, that things went wrong when we have invoked an LLM, and LLM was prompted with a different information, which was not the right interpretation of the first question that we asked to an agent.
And so, where do you think the industry needs to go with this observability? Like, what tools are we missing right now that would help us build a more reliable agentic systems?
I think honestly, my answer for that would be like we don't have a shared language for this agent quality right now. Like a lot of these teams right now are working on building these agents, but none of the teams are answering whether the agents can be tested and can be proven that okay, 99% of the time it will be correct. How can I trust agent? That trust language is still like a big gap in the industry today, because every team right now is inventing their own evaluation framework from scratch. And we need the equivalent of like what JUnit has done for code testing, right? That this is what a unit testing framework looks like, and you write the test to make sure that your code coverage and everything is correct. Similarly, we need like some standardization across like what makes agents decision right, and how can we sort of like gain confidence over the agent's correctness. And we need like a joint standard framework which can be applicable to everyone, rather than having like bespoke implementation by every team to make sure their agent is doing right.
We have something like that in ContextQA, which is called Production Readiness Index that we just launched. And yeah, I think this is the first step on the way there. We just published it last month. So it sounds like that the quality engineers have to really look into this and work on this, because they have that experience of kind of evaluating the code quality, right? So I know it's a different kind of system, but I would think their skills would be very applicable here. So what do you think, what would you recommend to QA engineers do right now as they get more comfortable testing these agentic systems?
Yeah, my recommendation for the QA engineers would be like for agentic systems, especially like you cannot use the standard practice to test an agentic system. Like static test cases will never work for them. The behavior emerges from the interaction when it happens with the model, the tools it can reach to, and also the state of the world. Like what was the prompt given to a particular agent at that point of time, right? So I think QA engineers have to change the mentality from writing the static test cases to thinking like how an agent can be validated using the decision boundaries and not the outputs of it. Like, is the chain of thoughts by an agent was right or wrong? You can judge that, but you cannot judge the output of that chain of thought. So those kind of like validations, or I would say mental model, has to be developed or even thought about when writing a test case for an agentic system.
And if a team is just starting to introduce AI agents into their pipeline, what is the first thing they should do?
Yeah, this is like, I'm going to give an advice which people might not like. I would say that don't start with like thinking that agent can automate everything and you have done it. And for one happy case, you are like celebrating your early win. Think about how you can start observing and building that observation for an agent as well before you like productionize it. You don't want to like celebrate an early win by saying that okay, the happy case that was in my mind has been solved by an agent by automating it. But what if like 90 cases of the time it's just doing the work which is like creating more problem for you? So work on like thinking about while you're automating something, what is an observability framework that you can apply to make sure that you can judge that automation, you can validate that automation, you can see when an agent has gotten worse or is not doing the right things. So work on observability and tracking piece as well, rather than just doing the automation using agents.
That is a very good point. And also talking about the price, like how much tokens it spends doing what you're asking it to do, right?
Exactly.
And what are you most excited about in this space in the next year?
I'm looking forward to like understanding or maybe like seeing if there are like some changes that we will see or happen in the agentic space in a way that right now there's no contract between how the agent to agent communication should look like traditionally we had API contracts, that what is the inputs and outputs of API. Right now multi agent systems are basically agents yelling into each other with whatever outputs we decide to produce and share it with them. But I think we will need some strongly typed interface with agents communication, like what is the formal guarantee about what one agent has to like return to another agent and reliably consume it. That's when like agentic architecture become truly testable, when once you start like defining the concrete boundaries between what one agent should be returning back to the another agent.
Yeah, sounds like, yeah, that's what we do need very soon, right? If we were to make these multi-engine systems work. Thank you so much, Vasu, for sharing your experience and your journey in this agentic AI world. And where can people find you if they want to connect with you or continue the conversation?
I'll be available on LinkedIn, so people can reach out to me on LinkedIn. I'm mostly available there.
Awesome. All right. Thank you, everyone, and we'll see you next time. Bye.
Thank you.